Hi guys, it's a trusted teacher, Kaumaji Mwansa, and welcome to Learning Science the Easy Way. So basically in this lesson, I'm going to look at matter, look at the states of matter, and as well as the changes of the states of matter. Okay, so matter. So we are saying matter is any substance that has volume and mass. Matter is any substance that has volume and mass. And when you look, we try to break down these two terms. You'll find that volume, this is just the space occupied by a substance. Then when we talk of mass, this is the quantity of matter in a substance. The quantity of matter in a substance. So we're saying matter is any substance that has got volume and it has a mass. That is what we call matter. So matter is made up of very tiny particles which you cannot see with the naked eyes. And these particles that matter is made up of are already in a motion. They are already moving. They possess the energy to move. They possess the kinetic energy. So they are already in motion. So in short, we are saying matter is made up of tiny particles which are in random motion. They are already moving. So it is made up of particles which are in motion. Okay, so now we can try to look at the states of matter, the states in which matter exists. So matter can exist as, so it says states of matter. States of matter. So matter can exist as a solid, liquid, and a gas. So matter can exist in the form of a solid. It can exist in the form of a liquid. It can also exist in the form of a gas. Okay, so now the arrangement of particles in the three states of matter is so much different that even just by looking at them, you'll be able to tell that this is a solid, this is a liquid, and this is a gas. So when you look at the solid, the arrangement of particles in a solid is so compacted. They are so close to each other that these particles are not even able to move. Instead, they just vibrate in their fixed position. They are able to vibrate in their fixed position, but they do not make those movements. They are just able to vibrate in their fixed positions. Then we have the atoms in liquids. The atoms in liquids, they are close, but there is space. They are spatially arranged. They are spatially arranged that they are even able to make movements. So in liquids, there is slight movements, which is shown. Then we also have the particles in gases, which are free to move. So the particles in gases, they are spatially far apart from each other in the sense that they are even able to move from one point to the next. So now, in terms of kinetic energy, you'll find that the particles in gases, they possess more kinetic energy than the particles in liquids and in solids. So the particles in gases, they already have more kinetic energy because they are free to move from one point to the next. So these three states of matter, the solid, liquid, as well as the gas, they are subjected to change when they are exposed to different forms of temperature. When they are exposed to a lower temperature, they will change a form from one form to the next, as well as when they are exposed to a higher temperature, a state is going to change from one state to the next. For instance, when you talk of a solid, when a solid is heated, it will melt. And when it melts, it changes the state from solid to liquid. As well as when you continue heating, when you heat a liquid further, it is going to evaporate, meaning it is going to change the state from liquid to gas. So these states of matter are subjected to change, are subjected to physical change when they are exposed to different forms of temperature. So when a solid is heated, it changes into a liquid. So a solid changes from solid to liquid, and when a liquid is heated, it changes from liquid to solid. So the change of state from solid to liquid is called melting. Melting is the change of state from solid to liquid. And again, the change of state from liquid to gas is called evaporation. So evaporation is the change of state from liquid to gas. Okay, so now, then there is also when a gas is cooled, when a gas is exposed to a lower temperature, it cools. As it cools, it changes the state from gas to liquid. So that change of state from gas to liquid is what is called condensation. Then the change of state from liquid to solid is called freezing or solidification. So now, there are certain substances that are able to change the states directly from solid to gas. And this change of state is what is called the sublimation. So there are certain substances, in short, that sublimes, that changes the state from solid to gas. And at the same time, there are some substances that are able to change the state from gas directly to solid without passing through the liquid state. So meaning this change, the change of state from gas to solid is what is known as deposition. So there are certain substances that changes that particular state. So when you look at this diagram which we have here, it is able to show the different changes of states, how solids as well as liquids and gases are able to change the states from one form to another. But the key thing is, do we exactly know what happens when a substance is changing the state? For instance, when a solid is heated, so when a solid is heated, the particles begin to gain more kinetic energy. As the particles are gaining more kinetic energy, they are vibrating more, meaning they increase in terms of vibrating. As the particles are vibrating, they begin to create space and be able to slide past each other. Now, when the particles reaches that state of slide passing each other, it means the solid has melted. It means the solid has changed the state to liquid. So same applies with the liquids. When the liquids are heated, or the particles of the liquids are heated, they gain the energy. They gain more kinetic energy. So when they gain more kinetic energy, they begin to move more vigorously. It will reach an extent where they will be able to move, to create more spaces, to move far apart from each other. And when they are able to do that, it means a substance has changed the state. It is no longer in liquid state. It is now in a different state. So this simply shows that the change of state from solid, liquid to gas requires energy, requires the intake of energy, and such processes are referred to as endothermic because they need energy for them to take place. So when we say endothermic, so this process is highly endothermic. it requires energy for it to take place. Endo means the intake. Then thermic from the word thermal, which means energy. So this process, this change of state from solid, liquid to gas is highly endothermic. So the opposite now happens when a substance is in gas form. It is going to condense. As it is condenses, it is releasing the heat energy, meaning it is cooling. As it is cooling, the particles begin to move slowly towards each other. So as the particles move slowly towards each other, begin to move slowly towards each other, they will have less energy to overcome the forces holding them together until they collide with each other. So meaning from here they are losing heat energy to the environment. As they are losing heat energy to the environment, they are moving towards each other. As they move each other, they are lessening, or they have less energy that will overcome the forces holding them together. In the end, they will be able to collide with each other. As the atoms collide with each other, then it simply means the substance has changed the state. It's no longer in gassy state. It is now in liquid state. Now, as the substance is in liquid state, when it is cooled further, as it becomes more cooler, meaning the particles now, or the forces holding the particles become so strong that they have less energy to overcome them. Now, at that point, the substance begins to solidify. It begins to form a solid. So as it begins to solidify, it simply means the particle or the substance has changed the state from liquid to solid. It has changed the state from liquid to solid. So that change of state from gas, liquid to solid, this one involves the release of energy. It is the opposite to the other. This one involves the release of energy, and such a process is what we call exothermic. Exothermic. Exothermic, we can say, is just to release. Then as well, that one is just energy. So such process is highly exothermic. So such a process is highly exothermic. I hope you followed through, and thank you for watching. But remember to subscribe to my YouTube channel so that you receive a notification whenever a new video is posted.